Hello everyone, welcome back to our OAuth 2 series. Today we are delving into the intricate world of OAuth 2 with a focus on the client credential flow. In this video we will exploring its role in OAuth 2 and understanding when it shines. We will cover its key components, scenarios when suitable, and compare it with other flows. Stick around as we break down how the client credential flow works and wrap it up with a practical example using Ory Hydra and Golang. Let's jump in. The client credential flow is a server-to-server flow, primarily designed for non-user-specific application-level authentication. Unlike other OAuth flows that involve user consent, client credential flow operates in scenarios where the client application itself seeks access to resources without acting on behalf of a user. In essence, client credential flow provides a mechanism for machine or services to authenticate and obtain access token directly, enabling secure communication between client applications and protected resources. Client credential flow finds its relevance in scenarios where the application needs to access resources that don't require user-specific permission. This is common in machine-to-machine communication, backend services interacting with APIs, or situations where user involvement in the authentication process is impractical or unnecessary. It offers a streamlined approach for applications to authenticate themselves and access protected resources efficiently. While powerful in specific contexts, client credential flow may not be optimal choice when user involvement is crucial for authorization. If your application requires access to resources tied to individual user account, or if user consent is a regulatory requirement, other OAuth flows like authorization code flow or implicit flow might be more suitable. Let's start by breaking down the key components of the client credential flow. The client, which could be a web application or a service, authenticates directly with the authorization server using its client ID and client secret. As we mentioned before, unlike other flows, there is no user involvement here. It's a direct interconnection between the client and the authorization server. Authorization server plays the role of the gatekeeper responsible for authenticating and authorizing client. Once authenticated, the authorization server issues access token to the client, granting it permission to protected resources. Protected resource is a valuable asset that the client aims to access. That could be user data, services, or any other sensitive information. Let's proceed with requesting access token using client credentials. The app initiates the process by sending its application credential to the authorization server. The authorization server validates the received application credentials to ensure the authenticity of the app. If the application credentials are valid, the authorization server responds to the app with an access token. The app, now in possession of the access token, uses it to make a request to the protected resource. The IP, upon receiving the request, contacts the authorization server to validate the provided access token. The authorization server confirms the validity of the access token to the API. With the validated access token, the API processes the request and responds to the app with the requested data. That's all. Manual flow. Let's download Hydra source code. I have already downloaded it and start our Hydra application in Docker Compose. Let's check in my Docker desktop app. Yeah, it's already started. First of all, let's create a new client to perform the call. Client name and client secret is kind of obvious field. What about grant type? Grant types field specifies the grant type that the client is allowed to use. In this case, client credential. that is used for obtaining access token on behalf of the client app itself rather than on behalf of a user. Scope. The scope parameter defines the access level that the client is requesting. In this example, the client is requesting the red scope. The scope is a mechanism in OAuth 2 to limit the access rate of the access token. And the last field, token endpoint auth method. This field specifies the method that the client will use to authenticate with the token endpoint of the authorization server. In this case, client secret post indicates that the client will send its client credentials using the HTTP post method when making request to the token endpoint. So let's create HTTP status created, and we need our client ID to perform the flow. I copy it. Trying to get protected resource without valid access token. First of all, without auth at all. Unauthorized. With OAuth token. It's not all token. I'm already testing it. Let's make it wrong. Unauthorized as well with invalid token. How the application understands token is valid or token is not valid. Your application will use introspected point that Ory Hydra is provided. It's part of Ory Hydra API, and your application sends token and scope to check it. False, active. Let's get the new token with our client ID and client secret. We will use token endpoint of Ory Hydra and send grant types, client ID, client secret, and scope. Status HTTP 200 awk. Let's copy our access token. Introspected is what your protected resource app will really do in the backend side. Yeah, the most interesting thing for us is that active is true, scope is red, and client ID is known for us. Let's get the protected resource with this token. And now we have 200 status, HTTP status is awk, and we can see that our protected resource is available with this valid token. That's all. In the next step, we will create app with Golang and Ory Hydra. Let's start with create new project. Create main.go file. Package will be main as well. Let's define constant for Hydra admin URL. It's part of official Ory Hydra API with token introspection endpoint. And let's also define our required scope. Required scope will be red, only red operation is acceptable. Let's create main function, create a generator instance. The gin package is not imported. Let's import it. Okay, gin is imported. Define a router for secure resource. Handle secure resource function will be written further. Get the port from the environment variable or use the default port. And run the server on the specified port. In case of error, just log it. Let's define our handle secure resource function that handles requests to the secure resource endpoint. Input is GIN context. Output will be JSON response with secure resource or error message. Extract the token from the authorization header. Return an error response if the token is missing. The HTTP status will be unauthorized, and error message will be unauthorized as well. Next, introspect the token to validate its validity. The introspect token function will be created further. And return an error response if the token is invalid or inactive. Create model for token introspection. I will create it via officially Hydra API, just copy JSON and use convert JSON to go struct up. Create new package, token info.go, and just paste after our generated structure. I will call it token info, and this will return via introspect token. Let's print error response if token is invalid or inactive, and log error as well. And respond with JSON. HT status will be unauthorized in this case, and error message will be invalid token. Check if the token has a required scope. The function has scope will be implemented in the next iteration. And log an error response if the token lacks of the required scope. I think insufficient will be more clear than invalid. And return error response as well. In this case, status will be forbidden, and error message will be insufficient scope. I forgot about return statement in each case of error. Let's add it. And if scope and introspect function return good result, return the secure results because all checks pass. Create map string and simple message. This is a secured resource. And return client ID from our introspect token function. And return JSON with our message and HTTP status log. Let's create our introspect token function that performs token introspection with Hydra. Input will be token state and output will be pointer to token info struct or error. Let's start with trim the bear prefix from the token. Not forget about space after bear word. And let's next create an HTTP request for the token introspection. The method will be post as we described before. Use Hydra URL from our constant. And create body with our token and required scope. Return an error if request creation fails, and log the message with error itself. And not forget about return statement. Next, set the required headers for the introspection request. Our first header will be content type with application XWB form URL encoded. And the second header is accept application.json. Our request is ready. Let's perform the HTTP request with default HTTP client. In case of error, log and return an error. If no error returns, decode the response body into a token info struct. Use our token info model that was created via JSON converter. And return an error if response body decoding fails. And log the message as well. Let's make log message pretty clear and return. And if everything is OK, return the memory address of the token variable and nil as error. Let's proceed with our second function, hasScope, that checks if a given token scope contains the required scope. Input will be token scope and required scope as a string, and output will be boolean indicating whether the required scope is present. First, split the token scope into individual scopes. And after that, check if the required scope is present in token scope. And we will return true if one of the scope has it. Return true. And if no one scope has it, return false. Sorry. Okay, looks like our function is working. Let's run it. Wait a little. Yeah, the program runs. Let's walk through the flow again, but this time let's take a closer look at how it operates in code. I will start with getting protected resource without token. Unauthorize, go to the code. It's this part, token is not present, so we have unauthorized error. Let's try to send not valid old token. It's unauthorized as well, but with other error message, invalid token. It's other part of our program. And let's try to send token with client which scope is insufficient. So create new client on Hydra without some scope at all. Send. Let's copy client ID. And delete scope from the token. Send. This is new token that client should get from authorization server. And let's try to get protected resource with token with insufficient scope. Yeah, we have a forbidden HTTP status as the scope is insufficient. And let's try to finally get our resource. I will create a new client with red scope. Send request to get access token. Copy the access token. And let's try to get protected resource with access token. Insufficient scope because I forgot. No, I not forgot about the scope. Strange. I forgot about the scope here. When we requested the token, we can specify or not specify the scope from the client side as well. So let's try it with new token. And yahoo! We have HTTP status log. So I hope that now the client connection flow is more clear for you. You understand the importance of a token endpoint URI. You understand what is scope is and why we use client ID, client second, and which grant types you should specify in this case. So if you have some questions regarding to OAuth 2, please write in the comments. I will try to answer or create a video about it. Bye bye.